Let's begin this review by talking about problems 1.1 and 1.2, making the box plot and the histogram for the 20 numbers that are listed here. To find the box plot, we first need to figure out some things. We need to figure out the low. We need to figure out the first quartile. We need to find the median. We need to find the third quartile, and we also need the high. Well, clearly the low is 0 and the high is 25. The median is going to be found by doing n plus 1 over 2. I have 20 entries, so that's 21 divided by 2, or 10.5. Okay, so I need to take the average of the 10th and 11th entries. So over here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th and 11th entries are the 9 and the 10. So the median will be the average of 9 and 10. So 9 plus 10 over 2, which is 9.5. To find the first and third quartiles, we find the median of the lowest 10 numbers and then the median of the highest 10 numbers. In those cases, n plus 1 over 2 would be equal to 10 plus 1 over 2, which is 5.5. So for this part of the data, from here to here, entries 1, 2, 3, 4, 5. So here's entries 5 and 6. So the first quartile will be the average of 7 and 8. Which is 7.5. On this part of the data, entries 5 and 6 will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. So the fifth and sixth entries are the 12 and the 12. And so the average of 12 and 12 would be obviously 12. So the third quartile is equal to 12. Okay, now I'm about ready to start doing the box and whisker plot. Before doing this, I have to get the interquartile range. The interquartile range is the third quartile minus the first quartile and that's going to be 12 minus 7.5, which is 4.5. Okay, so now I have to figure out the cutoffs for possible and probable outliers. First off, for the upper part of the course, upper part of the data, we figure out Q3 plus 1.5 times the IQR. So that'll be equal to, bring the calculator over here. So I need to take 1.5 times 4.5, take that and add that to the Q3, which is 12. So 18.75 will be the cutoff for any probable or possible outliers. Notice that 25 is going to be an outlier because that falls out is going to be that's larger than that cutoff. To figure out the probable outliers, same idea, Q3 plus 3 times the IQR. So again, pulling out the calculator. So 3 times the IQR plus the third quartile is 25.5. So 25 will be a possible outlier, but not a probable outlier, because 25 is less than that mark. Continuing, we need to get the cutoffs for the lower end of the scale. So same logic, we need Q1 minus 1.5 times the IQR. And so plugging into the calculator, we get let's see, 1.5 times the IQR is 4.5. That's 6.75. So if I add that to the IQ1, which is 7.5, I get 0.75. So that's going to be my cutoff for the possible outliers on the low end of the scale. So we see that 0 will be counted as a outlier. It's not going to be a probable outlier, however. If I figure out Q1 minus 3 IQR, that's going to be a negative number. Let's actually get it. So 3 times 4.5 is 13.5. So I need to take that plus Q1, which is 7.5, and I get negative 6. Clearly, everything is bigger than negative 6, and so I will not have any probable outliers for this data set. Okay, so now with that information, let's draw the box whisker plot. So I'll have a vertical line that goes like this. I have ticks at, say, 0, 5, 10, 15, 20, and finally 25. To draw the box, we have the median at 9.5. That'll be about here. The third quartile is at 12. The first quartile is at 7.5. So there's my box. I draw up to the largest value that is less than 18.75. So I'm going to draw up to 17. So that's the 17. And then 25 is a possible outlier, which gets a plus sign. Going down, I draw down to the smallest data value. That's still bigger than 0.075, so that's the 3. So I draw down to 3. And 0 gets special treatment, and that is treated with a plus sign as well. And if I had probable outliers, those would be denoted by the asterisks.